In this lesson, we're going to review linear functions. So recall that a function is linear if its graph is a straight line. And it will represent a relationship between x and y at any point on the line. X will be our independent variable, so that's the one that goes along the bottom, and y the dependent variable. That's why we often put it in the form y equals, because then y can easily be shown to depend on x. So we have two different ways to express our line, two main ways. We have the gradient intercept form, which is of the form y equals mx plus c. You'll see some old textbooks use b, but now we've gone to the c for the HSC, so we're going to stick to that. M is the gradient or the slope, so it's a measure of the rate of change. And c is our y-intercept, where it cuts the y-axis. We can also write our line in general or standard form, and that's where everything is on one side equal to 0. So we go ax plus by plus c equals 0. A, b and c are constants, and we'll see later on that as long as b doesn't equal 0, we have a function there. Now, probably the easiest way or the most useful way to sketch a line is to find the x and the y-intercept. So to find the x-intercept, we let y equal 0, and to find the y-intercept, we let x equal 0. Have a think about those points on the intercepts and you'll see why. So first of all, I usually find the y-intercept first. So to do that, we let x equal 0. However, because this one is in the form y equals, or f of x equals, I can see quite easily that the y-intercept will occur at -3. So it'll occur when the y value is -3. So I'll go down to -3, I'll put a dot, and I'll label it -3. The x-intercept, usually a little bit more work. Again, this time I'm going to let y equal 0, so I let the whole function equal 0. And I solve for x. And that will be 1.5. So picture it as 1.5, but we usually label with improper fractions. Once I've gotten that, I get my ruler and I join those with a straight line, arrows on the end, label it with its original name, that one that we started with, and really should label our x and y axes as well. Okay, so add those details in tests. So the domain, well, for any straight line, except vertical and horizontal lines, the domain will be all real numbers, and the range will also be all real numbers. Okay, we have no restrictions on what x or y could be. So in general, for oblique lines, our domain can be anything, our range can be anything, and yes, it is a function because it's going to pass, what's that way, the vertical line test. So oblique lines go on some sort of angle. Horizontal lines, yes, they will also be a function. Their x value, if we put dots along here, x could be any value you want. I could view it as x equals 3 or an x equals -2. So the domain could be anything. However, if you look at the y values on all of there, they are locked into one particular value, okay? And that comes from the equation y equals b. So our range, I will just write y equals b, b being whatever that number is in that particular question. A vertical line, well, that's not a function because here I draw a line, I hit it more than once, so it's not a function. The domain, well, x will be locked into one particular value. So for the graph, I've done it x equals 3. But in general, it'll be x equals something. The range, well, the y values can be whatever you like. There's an unlimited number of y values there. So the range is anything. All right, the next part, to find the equation of the line, identify the y-intercept if possible. Okay, so find out what c is if it's given in the question. If that's the case, then use the gradient and the form y equals mx plus c. However, sometimes you're given the gradient and a point, so you might have to use the point gradient formula, y minus y1 equals mx minus x1. Although the first one will work, you'll just have to be a little bit trickier with it, that's all. Okay, so find the equation of the line that has a gradient of 3. So I know m equals 3, and it passes through the point 2, -5. So this time I have the gradient and a point, so I'm going to use the point gradient formula. So we have x1, y1 being the point, so I'll go y minus -5, so that becomes y plus 5, put m in, and then x minus 2. We're then just going to expand and simplify that, and it doesn't tell me which form to put my line in, so the y equals form generally is the easiest. So there's the equation. To determine if the point lies on the line, I sub it in. So I sub the point 5, 8 in as my x and my y and see if it satisfies that equation. So y equals 3x minus 11. So I'm asking the question, does 8 equal 3 times 5 minus 11? Does 8 equal 15 minus 11? 4. They are not equal. Not equal. Therefore, not online. In example 3, we're not given the gradient, so we'll need to do that first. And we'll need to do, I'll just go back here, use this formula here, y2 minus y1 over x2 minus x1. So it's the difference between the y values divided by the difference between the x values. So x1, y1, I'll just make that the first point. x2, y2, the second point. You can put them in the other order if you like, but just don't trick yourself. So now to get the gradient, I'm going to go 12 minus 4 over 1 minus -2, so it becomes a plus. Work out the top, that's 8. Work out the bottom, that's 3. And sometimes we might have to simplify that fraction, but not in this case. So now I'll just use whichever point I like. I might use the -2, 4 because 12 just seems a bit ugly. So I'm going to go y minus y1 equals m x minus -2, so x1. Expand my bracket. Oh, I don't want to get my calculator, so I'm going to wing it. And then add that 4 to the other side. So that will be 12 on 3, 28 on 3. Check that, I've done that in my head very quickly. So just check that 16 over 3 plus 4 does equal that. I'm sure you'll tell me in class if I've gotten that incorrect. So the final example we're going to look in this video is a direct variation or a direct relationship or a direct proportion. What this means, if you have a problem where two things are directly related, it means as one increases, so do the others. And this one here we saw a little bit before with simultaneous equations, so this should be fairly easy now. So Peter owns a publishing company and sells calendars for $30 each. So I'm going to let him sell X calendars. This means his income or his revenue would be 30 lots of X, 30 lots of the calendars he sells. The cost of producing this, so now we're doing a cost equation, is $5,000. So that's like my y-intercept, plus $5 per calendar. That's like my gradient, 5x. I've written it backwards, but that's okay. What is his break-even point? So my first option is I could graph those and try and find the point of intersection. And some questions will get you to do that, but they will make sure they explain that clearly. You'll have graph paper, it'll ask you to graph, etc. We can solve it with similar equations, simultaneous equations. So break-even means your cost equals your income. So 30x has to equal the 5,000 plus 5x. So 25x has to equal 5,000